Okay, so now we will discuss this question. So this question is also asked from stratified random sampling. Now let's read the question first. A wholesale food distributor in a large city wants to know whether demand is great enough to justify adding a new product to his stock. To aid in marketing his decision, he plans to add this product to sample of the stores he serves in order to estimate average monthly sales. He only services 4 large chains in the city, right? So in the city, he serves in 4 large chains, mean they are stratum, right? So the stratum size K is equal to 4 here, right? Normally we denote the number of stratum using K, right? Now N, capital N is equal to 120. Now in the A part they are asking, suppose that the distributor takes a simple random sample of N is equal to 20 and do a simple random sampling. The standard deviation of the sample was standard deviation of the sample S square is equal to, they have given the standard deviation, right? So that is not S squared, that should be S. So now they have given the S value, that is 59.8. Okay. Estimate the variance of the sample mean, right? So X bar variance of X bar is asked here, right? So now this is if we consider this as simple random sampling, so this will be SRS is equal to S square divided by N minus N divided by N, right? So now the data, all the values are given in the question itself, so we can just substitute and get the answer. So 59.8 divided by 20 into 120 minus 20 divided by 120. So what is the value? So you should get the answer as let me just calculate it. I'm sorry, here there should be a square, right? 59.8 square divided by 20 times 100 divided by 120. So the answer is 149.007. So this is the answer. 0.0017. Okay, 17. Right, now they are asking estimate the variance of the sample mean. We have done the first part. Now we will move to the second part. If you read the question, they are telling for administrative convenience, he decided to use stratified sampling, right? So now even though he serves in 4 large chains, now he in the first question he considers all chains as one and performing the task, right? But now for administrative convenience he decided to use stratified sampling, which each chain is a stratum. Below table shows this monthly cost for each stratum, right? So monthly cost of each stratum is given. Okay, monthly cost of each stratum is given. Okay, so the stratum 1, the cost is this. Okay, but the cost is not this. Okay, anyhow we will just read this, right? So the data, something is given and the summary data also given, right? So they have given NI stratum size, right? So stratum size xi bar, x1 bar, then SI square, right? SI square is also given. Now based on the sample size allocation in the above, determine the type of sample size used, right? So determine the type of sample size used. So now what they are asking is type of sample size type of sample size allocation used, right? So since they have given the cost, we have to use this what do you call optimum allocation. But I don't think the cost is given. There should be a mistake or there is an ambiguity in the question, I think, because we may take this as Newman allocation also, right? Because optimum allocation variance and Newman allocation variance is the same. So now for this, I think the answer should be Newman allocation, because since the cost is not given, we cannot use the formula that we studied under optimum allocation, right? So I think for the first one, the answer should be under Newman allocation, right? So for the first one, Newman allocation. Now the second one, estimate the average monthly sales and place a bound on the error of estimation. Now x bar stratified is equal to summation ni xi bar divided by capital N, right? Now the capital N is 120, that is given, and if we add all these stratum sizes, you will obtain this 120, right? So from this you can tell N is equal to 120. Now Ni into Xi, so 24 times this one, X bar stratified, 24 times, this is Xi bar, right? So 24 times 99 plus 36 into 100 plus 30 into 100 divided by 200. So the answer would be 24 into 99 plus 3600 plus 3000, 8976 divided by 200, that is equal to 44.88, right? 44.88, that is X bar stratified mean. Okay. Estimate the average monthly sales and place a bound on the error of estimation. So now we have to calculate this variance of X bar stratified. For that we have studied an equation. Oh wait, there cannot be this much variation. We have made some mistake, I think. Have we calculated? We have calculated correctly, but there might not be this much variation in the mean, right? So 24 times 99, 36 into 100, 30 into 98, 30 into 98, 30 into 98, 30 into 98 plus I forgot to add this also, right? 30 into 100. Okay, in the numerator I forgot to add the add one stratum value, right? So here the answer would be so here the answer would be what is the answer? So now the answer would be again, why am I putting 200? This should be 120, right? Oh, 120. So the answer would be 99.3, right? So you should be very careful. And variance of X bar ST, right? So at Newman allocation. Now you see here for this we have the equation. but under Newman allocation we haven't calculated the sample sizes, right? So now we will first calculate Ni is equal to N into Ni Si divided by summation Ni Si, right? So because under Newman allocation we have this equation for finding out the variance, so that is 1 divided by n square summation Ni minus Ni Si squared, I'm sorry, what is it called? Ni minus 1 Ni minus Ni Si squared divided by Ni. Okay, so I think this is the equation for finding out the variance of x bar stratified under Newman allocation. Okay, let me just check it again. Yes, that is correct. So now we have to find out the sample sizes for each strata separately. So now we need one more column that is Ni into Si. So Ni into Si, we have to make that table, right? So if we have any questions in stratified random sampling, then we have to make this table so that we can easily get the answers, right? So the first work that you should do is to convert the given data into a table, where in the first column you write the stratums and then the remind or the necessary things, right? So now we will write stratum. Okay, the given values are we have 4, right? So here we have 4, 1 2 3 4, and for summation, for total also we will not read another row. So now this is Ni, this is Xi bar, and this is Si squared, this is Si squared. Now we need Ni into Si in order to find the sample size for each stratum. This is 1 2 3 and 4. This is 24, 99, 78.67, and here 36, 100, 98. Okay, no, 3600, 55.6. Okay, 55.6, 55.6, 55.6. Then here 30, 98, 35, 39.5, and here 30, 100, 112.5, right? So these are the values that they have been given, and using your calculator you can easily find out Ni into Si, right? So 99 into square root of 78.67. Okay, so that would be equal to 212.87. 212.87. Then again 100 into square root of 55.6. 100 into square root of 55.6. 55.6. So that gives me 745. 745. Oh, I'm sorry. This should be 36 into, right? 36 into 268.44. 268.44. Again 30 into square root of this. 30 into square root of this. Okay, and here also 24 into square root of this. So it gives me 118.55. 188.55. 188.55. And here 30 into square root of this 112.5 gives me what is that? 318.2. 318.2. So I need the summation of these values. So it is like 988.06. 98.06, right? Okay, so now we can calculate n1. N1 is equal to the Sn. Now we have to take 20 samples, right? So the total n is 20 into this one, 212.87 divided by 988.06. Okay, and again we can calculate it for n2 also. 20 times 988.06 for this one, 268.44 and again n3 is equal to 20 times 188.55 divided by 988.06, and n4 is equal to 20 times I think 318.2 divided by 988.06. so if you simplify these values, you get n1 is equal to 4.3, right? So 4.3, so approximately equal to 4. Again n2 is equal to 5.48. So this is like now 5.5, so I can write like approximately equal to 5. Again this one 3.82 is approximately equal to 4. Again this one 6.44 approximately equal to 6. Okay, now if I add all these, then I get 10 and 19 only, so I can just write this also as 6. Yeah, that is also 6. Okay, that is also 6. Okay, right. So now we will just see this second one. Okay, so 1 over n squared, n is equal to 120 square summation ni minus ni. So now this is ni minus this one. Okay, this one here, this is the equation that we have to use here. So now 24 minus 4 into 24 into SI is equal to, for this value SI is equal to what? SI squared is equal to what? In this column we have 78.67 divided by n is equal to 4 plus again for the second one, the stratum size is they have given 36, 30, okay, 36 minus 6, yeah, I found 6, yes, into 36 into this one 55.6 divided by 6 plus again 30 minus 4 into 30 into 39.5 divided by 4 plus again 30 minus 6 into 30 into 112.5 divided by 6, and again I have to multiply this. Okay, that's all. So now if I simplify this, I will get the answer. Okay, so I should get the answer as 2.9339 should be the answer. You may check it again. Okay, sometimes I might have mistake. I might have done mistake. So you had better check the answer and let me know if I was wrong. Okay. In the comment section, you can just drop your doubts, and if I have made mistake, you can just mention them in the comment section. Okay, now we will just move to the next one. estimate the average monthly sales and the place and the bound on the error. So variance of x bar st. So bound on the error of estimation is equal to 2 into square root of variance of x bar st, that is equal to 2 into square root of 2.9339. So the answer would be they asked about this variance of x bar. Yeah, so the answer would be 2 into square root of 2.9339. 3.42, right? 3.426 is the answer. Okay. And they are asking estimate the average monthly sales in the place of the product. Compare and comment on your answer variance in the. Okay. Now what we have to do is we have done already the first one where we found out the variance of x bar is simple random sampling. It was 149 point something. Okay. And then now we have calculated this variance of x bar at Newman allocation, that is 2.99. So when compared to the variance in simple random sampling, this is very small. So this method is more efficient. So this is what they are asking in the next third question. Compare and comment on the answer in A and B. Okay. So when comparing, this is very simple. So efficiency is greater for stratified random sampling. Okay. Variance of x bar SRS is greater than variance of x bar stratified at Newman allocation. So we can conclude that efficiency of this Newman allocation is more high, right? So that is what they are asking in the next question. Now we will discuss another question that is coming in systematic sampling technique. Okay. Right. A college is concerned about improving its relations with the neighboring community. A 1 in 50 systematic sample of the N 1500 students listed in the directory is taken to estimate the total amount of money. So they want to calculate the total amount of money, right? So that's why they have underlined that one. Spent on clothing during 1 quarter of the school year. The results of the sample are listed in the accompanying table. Okay. So now what we have to know is N is equal to 1500 and K is equal to 50, right? So now we can calculate N, that is equal to N divided by K, that is equal to 1500 divided by 50. So now this will be equal to 30, right? So we have to take 30 samples. Yeah, they have taken 30 samples. From here also you don't need to actually calculate it, right? Anyhow, you should understand, right? So what they are asking first is use the above data and estimate and place a bound on error of estimation. Okay. So now what you have to do is you have to calculate the x bar systematic, right? So x bar systematic is equal to, so x bar systematic is equal to summation of xi divided by n. So summation of xi means you have to add all these values. Okay, all these values. If you add all these values, you get 850 divided by 30. So the answer is 28.333. Now we can find out the SI squared, right? S squared is equal to summation xi minus x bar holding square divided by n minus 1. So now this is equal to, we can use this equation also. summation xi squared minus summation xi, or n into x bar, n into x bar squared, which since we have known x bar, so n into x bar, n into x bar divided by n minus 1. Okay, now if you use this one, this should be equal to so I calculated this, so it becomes 33904 minus n is equal to here 30 into x bar, we calculated 28.333 divided by n minus 1, right? 30 minus 1. So the answer should be minus 30 into 28.333 one one 7934. As usual, I should have done some mistake. Let me check again. Okay, I found the mistake. Okay, I don't know why this happens to me. So this is supposed to be x bar square. Okay, x bar square, x bar square. So if you simplify this, you should get 338.663. Okay, so this is the answer. Now we will look at, so estimate the place. So now we have to find out variance of s square, right? Variance of x square. Now we have to find out variance of toe head, right? So we have to find out variance of toe head, because estimate the total money taken to estimate the total amount of money. So total amount of money means these are dollar, right? So total amount of money is equal to 1500 into toe head is equal to x bar into n, right? So 1500 into x bar systematic is equal to 28.333. So 1500 into 28.333 is equal to 42499.5. Okay, right? And we have to find out the total variance of total, right? Variance of toe head is equal to n squared into variance of x bar systematic sampling. So now this is equal to what? This is equal to what? N squared. Now for systematic sampling, s squared divided by n, n minus n divided by n, right? So now 1500 into s squared we have calculated 338.663 divided by n is equal to 120, 30, right? 30 into 120 minus 30 divided by 120. So if you simplify this, no, why am I, okay, so this is not 120, n is equal to 1500, okay, we have to be very careful. So I'm 1500, okay, 1500, 1000, 1500. Okay, so if you simplify this, you should get the answer as 24.8904. Let's just check, right? Okay, so if you simplify this, you should get the answer as 2489170305, right? 0.5. So this should be the answer, variance of toe head. And we have to place the bound on error. B is equal to 2 into the square root of this value, and you can find that value also. And B part, what sample size needed to estimate in A with the bound on the error of estimation approximately equal to this one. So B is equal to given as this, right? So using that, we have to find out the sample size. So for B part, what we have to do is, let me erase all this stuff. Okay, for B part, B is equal to 1000, right? No, 10,000. So D is equal to B squared divided by 4. But this is for estimating the sample size for proportion and mean only. This is for proportion and mean. But if he asks to find out the sample size for determining the total, then we have to use B squared divided by 4n, right? So B squared divided by 4n squared. Okay, 4n squared. So for finding out the total, we have to use this equation, B squared divided by 4n squared. So 10,000 square divided by 4 into 1500 square. So now this is equal to 11.1111. Now n is equal to n sigma square divided by n minus 1 into d plus sigma square. Now we already calculated the sigma squared as some value 24891, right? Sigma squared. Now this is here, the sigma squared is equal to, consider now this s squared, okay, that is variance. So this s squared is going to be replaced by this sigma squared. So this becomes 1500 into 338.663 divided by n minus 1, 1499 into 11.1111 plus 338.663. So if you simplify this, 1500 minus, into 338.663 equal divided by 1499 into 11.11 plus 338.663. So equal 29.8. So approximately equal to 30. For this bound on the error, we have to take 30 samples. Okay, right. So hope you have understood these two questions, and we will meet on another video. Bye.